Okay, so let's try to record this video this way. Um, this video is going to be on beginning first part of 4.2 linear relations, how to recognize linear relations from graphs and data tables. I guess first of all, greetings, my students. This is another session, math session with Mr. D's math class. Okay, so this time I'm just going to show you the pictures I've already drawn. If you want to recognize linear relations from graphs, well, it's very simple. Okay, if you're given a graph like this, if the line is straight, no matter what direction it's slanting, if it's sloping up, if it's sloping down, if it's dotted lines that are lined up in a straight line, then these are all yes, these are all linear relations. Why? How do you know? Well, because they're all straight line graphs. Okay. In contrast, graphs that are curved or that are not straight, well, obviously they are not linear relations. Well, because they are not straight line graphs. Okay. And that's really the real big difference. So here's another one where the plots are actually all over the place. So this one is also no, there is no straight line. Okay. So that's a brief description on how to recognize graphs that are linear relations. Strictly if they are straight, okay, or not, okay. So if you want to look at now data tables that are linear relations, well, how can you tell if a data table is a linear relation? Well, it's also pretty simple. You just make sure that as one variable is constantly changing, in this case, the x is constantly increasing by 1, and the other variable is also constantly changing or has a constant change throughout, as in this y is constantly adding by 3. Okay, if it's the same value, from one to the next, then that means that is a yes. That's a linear relation data table. Okay. And for our class, how do you describe it? Just keep it simple. Okay, as x increases by 1, y increases by 3. That's it. Okay. So maybe now is actually, why don't we try this? Why don't we try, let's try getting the algebraic equation for this. So the algebraic equation actually is y equals, okay, something multiplied by the x. Okay, and then we're going to find out what the constant is, or the adjuster. But in this case, I've told my class that this is the number that immediately multiplies the x. Okay, so we have 3x so far. And then the adjuster, well, we just try it with one of these data sets. In this case, let's try it with 1. If x is equal to 1, what is 3 times 1? Well, 3 times 1 is 3. What do you have to do to 3 to make 4? You just add 1. So there is our algebraic equation. Okay? Just thought I'd review that really quick while it's here. And you can do that trick with any linear relations or linear pattern data tables. What's an example of not a linear relation data table? Well, it's right here. Okay, you notice that the x is constantly changing by 1, but the y, it's not constant. See, it's from 2 to 6, it increased by 4, and then 6 to 12, it increased by 6, 12 to 20, it increased by 8. So, in this case, this is not a linear relation. By reason, as x increases by 1, y increases by 4, then 6, then 8, etc. And so this is the kind of reasons I want you to give me when you get your assignments, okay? For data tables, yes, as one is changing so-and-so, the other one is changing by so-and-so, or as in not, okay? I hope the video helps, and I wish you luck on this assignment when we're done with all the focus. I think the next video I will show you will be on how to graph data tables properly. Bye for now.